These are little things that make a big difference on the math section of the SAT. So if you would like to pause this video and attempt these problems, please do so now. The first section, the chart 1 through 5, is asking you to simplify if possible. You will not be able to simplify all of those. The next section, 6 through 21, is simplifying also, combining like terms. And the last section, 22 through 29, is just some basic equation solving. So again, I would go ahead and hit pause to try these. And in the next slide, I will review the answers. Okay, so looking at the chart, the first row, to add x plus x, you get 2x. You can think of that as 1x plus 1x, combining like terms. They have the same variable with the same power. Subtracting x from x for the next item will always get you 0. And the multiplication, a variable times itself, would be the same as squaring that variable. For the last column with division, x divided by x would be 1, with the exception of x being 0. If the value of x is 0, then that would be indeterminate form. So there should be some fine print there to assume that x is not equal to 0. But for the division, x divided by x, a variable divided by itself, any number divided by itself, should get you 1, again, with the exception of 0. For row 2, x plus 1, you cannot do anything there. They are not like terms. Without having more information for the value of x, you cannot simplify. Likewise, for the second column with subtraction, x minus 1, you cannot be simplified. Those are not like terms. For multiplication, x times 1 would be simplified to just x. When you multiply by 1, you will always get your value back. And then lastly, for that row, x divided by 1 would be more simplified as just x. When you divide by 1, it does not change the value in your numerator. For the third row, we have addition with 1 plus x. Again, you cannot simplify that. Just like row 2, they are not like terms. Addition is commutative, so x plus 1 is really the same as 1 plus x. Neither of those can be simplified. For the second column, subtraction, 1 minus x, subtraction is not commutative, but those are still not like terms, so you cannot simplify there. For multiplication, 1 times x, with multiplication being commutative, just like addition, is the same as x. And for the last column, division, 1 divided by x cannot be simplified. Division is not commutative, so it is not the same as x divided by 1. 1 divided by x cannot be simplified when the 1 is in the numerator. For the fourth row, we have 0 involved now. So x plus 0 will always be x. Even though those are not like terms, 0 is nothing. So anything plus nothing is that anything. So just simplify to x there. For the subtraction column, x minus 0, again, still not like terms, but because you're subtracting nothing, you can simplify to just x. For the multiplication, x times 0, anytime you multiply by 0, you will always get 0. And for the last column with division, x divided by 0, you cannot divide by 0. So therefore, that one is undefined. Again, the fine print for that one, just like the row 1, would be assuming that x is not equal to 0. So anything divided by 0 is undefined with the exception of 0 itself. For the last row, 5, still dealing with 0, but the opposite order. So we have 0 plus x would still be just x. Again, addition is commutative. For subtraction, 0 minus x would actually be negative x. Since subtraction is not commutative, when you switch the order of the x and the 0, that simplifies to negative x. And for multiplication, 0 times x is still 0, because again, multiplication is commutative. Division, 0 divided by x will always be 0, except for if x were 0 itself, right? So we go back to that special case where if you would take 0 divided by 0, that would be the indeterminate form, but 0 divided by anything other than itself will always get you 0. Okay, so that's it for the chart. Moving on to some others with basic operations, simplifying, combining like terms, just some basics. So for number 6, 3x plus 3x would simplify to 6x. For number 7, 3x minus 3x simplifies to 0, nothing. A common mistake there is to still want to write the x. You could write the x, but it would have to be 0 times x, which is more simplified as just 0. Number 8, 3x times 3x is 9x squared. So just like in our chart, when we had x times x, we got x squared. Because you have the coefficients of 3, 3 times 3 would give you a 9 there. Again, with multiplication being commutative. And for number 9, anything divided by itself, 3x divided by 3x is 1. Again, the fine print is we are assuming that x is not equal to 0. For number 10, 6x plus 2x would combine, simplify to get 8x. Number 11, 6x minus 2x would simplify to get 4x. Number 12, when we switch to multiplication, 6x times 2x, we can multiply the 6 times 2 to get 12. And again, x times x is x squared. Simplifying for number 13 with division, 6x divided by 2x would simply give you 3. We just give you 3. The x divided by x would simplify to 1, like we saw in the chart. Again, assuming that x is not equal to 0. Number 14, you cannot simplify. Those are not like terms. Number 15, you cannot simplify. Those are not like terms. Number 16, 6x times just 2 would simply give you 12x. And 17, 6x divided by 2 would give you 3x. You just divide the 6 by 3 and then multiply by x. 6 by 2 rather, to get 3. Number 18, 6x plus 2x plus x would simplify to 7x plus 2, and then you cannot simplify any further because those are not like terms. Same with number 19, you would take the 6x minus x, or 6x minus 1x to get 5x, and then minus 2, again, you don't have like terms, so you could not simplify any further. For number 20, we have 6x times 2 plus x. So just like in number 16 above, 6x times 2 would be 12x. We add another x, and now we have like terms, so we can simplify that by adding to get 13x. And for number 21, you cannot simplify. This causes a lot of little mistakes. A lot of us, when we first look at that, want to cancel out the x's, but because you are multiplying in the numerator in the top of the fraction, but adding in the denominator, the bottom of the fraction, you cannot actually divide the x by x like we did in number 13. So you cannot do anything there. The other common mistake is to take 6 divided by 2. But again, the 6 is being multiplied by x in the numerator, and those terms in the denominator are being added. You cannot separate those to do that division. Number 22, we're just solving a two-step equation. Add 1 to both sides and then divide by 2. Number 23, you can combine like terms on the left side to get negative 5x, and then subtract your 2. And lastly, divide by negative 5. Negative divided by negative turns out positive. For number 24, you can distribute that 5 to get 5x minus 15. Then you could add 15 to both sides. Another option would be to divide by 5 first. Either way will work. And lastly, for 25 in this row, we have the variable on both sides of the equation. So as it's shown here, we added 3x to both sides, but you could just as easily subtract 2x from both sides to get all the variable terms, all the x terms on the same side of the equation. Likewise, you do have two other options. You could have added 9 to both sides or subtracted 5 from both sides, but my recommendation would be to get the variable on the same side as your first step. For number 26, solving this would be a system of equations, so you're solving for both x and y. You could use graphing, substitution, or elimination. I will have more videos posted on that. For 27 as well, you're solving for both x and y. You could use graphing, substitution, or elimination. This one has no solution because your variable terms will cancel out. If you use substitution or elimination, and your constants are going to be different on both sides. They will always be different. This will never, ever, ever have a solution. If you would graph those two lines, they would be parallel. So when you're graphing a system of linear equations, you're looking for the point of intersection. These two lines would never cross. So therefore, there is no solution for that one. And for 28, another system solving for x and y. We get fractions for answers there. Again, you could use graphing, substitution, or elimination. And lastly, for 29, again, solving for x and y, graphing, substitution, or elimination. This one has infinitely many solutions abbreviated with that IMS. This means those equations are exactly the same, and any solution that works in the first equation will also work in the second equation. If you would graph these two lines would be the exact same line. They would be overlapping. They would have every point in common, therefore infinitely many solutions. All right, I hope this quick review was helpful. Again, look for more videos that will show you more information on systems of equations.